Okay, so this is part two, follow-up lesson for what we talked about yesterday. We're just going to go similar but a little different types of problems. And so let's just get right into preparing you for the homework that you're going to be doing. You are going to need to do some graphing, so just go ahead and use the graph paper that I've given you for these first few samples, and that still should leave you enough graph sections to do the homework. So you'll kind of be using your notes and your graph paper to work through these problems. The directions say to find the vertex, focus, and the directrix, and then sketch the graph. Well, the first thing, just like we talked about yesterday, if you don't have the equation solved for a variable, that needs to happen first. And if you're wondering which variable to solve for, it's always the one with the lower degree. What I mean by that is the smaller exponent. So in this case, I'm going to solve this for y. And solving it for y helps me have a better understanding of how this parabola should open. And so the solve for y form will be y equals 1/4 x squared. I had to multiply by 1/4 on both sides to get y by itself. So what do we know now about this parabola? How does it open? Okay, it opens up. Just going to gather some information. What's the vertex? Well, if you don't see, here's a little tip for you. If you don't see any addition or subtraction in your equation, which we don't here, it's always the origin. So the vertex for this particular parabola has to be the origin. So it's going to open up from the origin. And now, how do we find the focus? And then pretty much, if you found the focus, then you should also know how to find the directrix. But how do we find those two pieces? Remember the formula? Okay, the absolute value of A is 1/4c, and we're given A. Now that we've turned this equation into solve for y form, we know what A is. A is 1/4. So it's a little bit different, I guess, than what we did. We're given A in order to find C. And you can do cross multiplication here if you need to. Cross multiplication means you multiply this way, 4c times 1, and you let that product equal the other cross product, 4 times 1 is 4. Probably could have gotten there a lot quicker just by looking, but if you need to do cross multiplication to find C, it's always available to you. Excuse me. So what is C again? What does it stand for? Distance from vertex to focus. And we also have to pay attention to how the parabola opens, because we're going to travel that same direction from the vertex. And so since this parabola opens up, I'm going to travel C places, one place, straight up from the vertex. And where does that put me? What ordered pair? If I go straight up one place from the vertex, I'm at what ordered pair? Yep. 0, 1. So that's the focus. And the directrix is still C units away, but it's in the other direction. So if I had to go up 1 from the vertex to get to the focus, I've got to go down 1 from the vertex to get to the directrix. And remember, the directrix is a line. And here's another tip for you. If your equation says y equals, which this does, your directrix line should also say y equals. It's got to be a horizontal line. So if I go down 1 unit from the vertex and I draw a line through that point, that's the line y equals -1. And now we've gathered all the information, so let's just go ahead and go to your graph paper and let's just put it all together. So I'm just going to do a little rough sketch. Right, so the focus, the vertex at the origin, focus is at the point 0, 1. Directrix at the line y equals -1. I usually just draw a dotted line to represent the directrix. And then just choose an input, an easy to manipulate input for this particular function. 2 is a good choice. There's really not a bad choice unless if you're trying to stay away from fractions, then we input 2, and what's the output? 1, okay? So the point 2, 1 has to be on the graph, and that means because of symmetry being around the y-axis, -2, 1 is also going to be on the graph. And so here's our rough sketch of this parabola. And that's pretty much going to be the routine for these equations where the vertex is at the origin. And you can always know that, again, if you don't see any plus or minus in the original equation, you know that the vertex has to be at the origin. Okay, let's try this one. Currently, it's not solved for anything. So the way I do this is I go ahead and solve it for the lower degree variable, which in this case is x. X has an exponent of 1. And to solve for x, I'm going to have to multiply by -1/16 on both sides. So I'm just going to turn it around. And the solve for x form looks like this. So it's solved for x, it's got to open, the parabola has to open either left or right. What's the case here? It's got to open to the left, okay? So you can, if you want to just kind of sketch the graph as we go, where is the vertex? The origin. There are no addition or subtraction operations within this equation, so I've got to have vertex at the origin. We've already established that this parabola has to open to the left from the vertex at the origin. So let's find where the focus is. Once again, absolute value of A is 1/4c. A is technically -1/16, but the absolute value of that's positive. Remember, C is distance, not direction. It's just how far. We know what direction to go based on how the parabola opens. So when I solve for C here in my formula, what do I get? C is 4. Okay, so I know now from the vertex, traveling in the same direction that the parabola opens, which is left, I'm going to go 4 places and put a dot, and that makes the focus then the ordered pair -4, 0. The directrix is going to be 4 units in the other direction, and it's going to be a line. And just remember, please don't tell me the directrix is 4. If it's a line, then it needs to have a linear equation. And the linear equation for a vertical line crossing the x-axis at 4 is the equation x equals 4. And now we just have to come up with an input. We have symmetry now around the x-axis. So give me a good input. This time, remember, we're going to input for y to determine x. So give me a good y input here. Any suggestions? 4, we can't go this way. I'm sorry, we can do, since we're doing y, yeah. We can do +4 for y. So if I input 4 for y, what do I get for x? 4 squared is 16, and what's 16 times -1/16? negative 1. So the point negative 1, 4 should be on my parabola. And because of symmetry, I know that negative 1, negative 4 must also be on the parabola. And so we'll sketch it. And we're done. Any questions so far? Okay, let's try another one. Is the vertex going to be at the origin for number 41? No. So let's do our normal routine. Our first step here is if I don't have a variable solved for, let's solve for the lower degree variable. Is that going to be x or y? It's going to be x, right? Because if I did square this binomial, I would get y squared. Here I would have x to the first. So I'm just going to make this in a what we would call vertex form, but you've got to be careful when it's solved for x. We got to be careful that we interpret the vertex correctly. So solving for x means I'm going to multiply by 1/8. If I'm doing something that you don't quite understand, let me know. And then I just have one more move to solve for x, and that is to subtract 1. Okay, now I've got to solve for x. How should this parabola open? Up, down, left, or right? Yes. Opens right. It's solved for x, so that narrows it down to left or right. And because a is positive, it's got to open to the right. Okay, so be careful. We're going to identify the vertex, but in this solve for x form, this is a little bit different. This is a little tricky for some people. The vertex is actually going to be negative 1 for the x coordinate and positive 2 for the y. We ran into that a little bit on yesterday's lesson. Okay, so on your graph paper, we'll just kind of sketch as we go. I'm going to go ahead and plot the vertex negative 1, 2. And we've already established that the parabola opens to the right from that vertex. So let's go ahead and plot the focus. Using our formula, absolute value of a, and we know that a is 1/8. Absolute value of a is 1 over 4 times c. So what is c? If we know what c is, and we know what the vertex is, then we can figure out the focus. So if I use cross multiplication, 4c equals 8. That means c is 2. So putting it all together, I'm going to go this many places from the vertex to the right, because that's how the parabola opens. So if I go right 2 places on this horizontal line, just go straight to the right 2 places, I am here. And my red dot has what coordinates? What are the coordinates here of this red dot? 1, 2. So that is the focus. To get to the directrix, I'm going to go back to the vertex. I'm going to go c places in the other direction, meaning left. So if I go 2 to the left and I draw a vertical line, what is the equation for that vertical line? Well, it should be vertical, not exactly vertical. Well, it's not going to be y if it's vertical, and 3 would be over here. Okay, x is negative 3 is my directrix. So far, so good. And now we just need an input. We're inputting now again for y in order to come up with x. So do you see a good choice for a y input? There's no bad choice really. Sometimes we just like to stay away from fractions. Give me a choice for input y. Emma, what do you think? 6, okay. 6 minus 2 is 4. 4 squared is 16. 16 times 1/8. 16 divided by 8 is 2. 2 minus 1 is 1. So when we input 6 for y, we got an output of 1 for x. So the point 1, 6 should be on the graph. And again, you're using graph paper. Yours will be a lot neater than mine. 1, 6, which is here. And I've got symmetry around this line right here, the line y equals 2. So 4 places up and gives me a point. So that means 4 places down gives me another point. And I'll just connect those. And that's my graph. Any questions so far? Sometimes it's a little tricky when the vertex isn't at the origin and you've got to locate the focus from that vertex. Everybody good? All right. Let's try one where we've got to complete the square. Right now we don't have vertex form, and we want to create vertex form because it's much easier to graph out of. So whatever the higher degree variable is, that's the variable we're going to complete the square on. Probably makes sense because when we complete the square, we're trying to do the square root of some variable, and it's got to be the one that's got exponent 2. So I'm going to be completing the square on y, and so to get this set up, I'm going to move the x and the constant over to the other side. Okay, completing the square on y means that I do my quantity squared. Remember, it's the square root of this first variable, which is y. Bring down the sign. And how do I get this number if I'm completing the square? Divide by 2. 4 divided by 2 is 2. Okay, with me so far? If you did square this, if you multiplied y minus 2 times itself, what would that trinomial look like? Can we do it mentally? Y squared minus 4y. We match so far. And then what's the last term going to be? The constant. Do you see where I'm going? Do you want to write it down twice and use FOIL? You don't have to write this. I'm just trying to get you to see why the next step is necessary. Y minus 2 squared means this. When I use FOIL, I get that. Well, what's the difference between y squared minus 4y and this? What's the obvious difference? The plus 4. So this creates plus 4 that this does not have. You see it? Okay. So how can I make my equation balance if I've got 4 added on the left side? What must I do to the right? Add 4, right? Correct? Okay. So I'm going to add 4 to both sides, and what's that going to give me? I've already added 4 on the left side. What happens on the right when I add 4? What do I get? Negative 4x, okay? I just wanted to do this little step so you'll see why this balancing is necessary. when you complete the square, you're going to be adding whatever this number squared is to the right side. You've already done it on the left. Okay, now we're pretty much back to where we were. We need to solve for x. So Lily, what's that look like in solve for x form? Okay, so what does that give us? Okay, and now we're solved for x. So let me get Shelby, how is this parabola going to open when it's graphed? Well, it's solved for x, so think x-axis. Yeah, it's going to open to the left. If it's solved for x, it goes like the x-axis goes. And with it being negative, it's going to open to the left. Okay, so can somebody give me the vertex? John, what do you think? Now, it's solved for x, so be careful. Remember, y is grouped with y. Well, we're going to do that eventually to find out the focus. Right now, we just want to look at this to tell the vertex. Our x-coordinate would be something added or subtracted to x. What's added or subtracted to x? Somebody want to take it? Yeah. 0, 2. Yeah, there is nothing being added or subtracted to x, so that's our x-coordinate, 0. The y-coordinate is this number, but we got to be careful to do the opposite. So 0, 2 is the vertex. We'll just list all of our information out here. Can somebody tell me, I'm just going to open this up. Has anybody already found the focus? So we're just going to jump right to it. You used the formula, you found C, you know which way to travel from the vertex. Anybody want to give us the focus? Stacy. -1, 2. Does everybody see how she got that? Do you see that C is actually 1 if you do your formula? Absolute value of A is 1 over 4C. So traveling one place to the left, because that's how the parabola opens. So then, Noah, can you give us the directrix? Well, the directrix is a line, so it's not going to be an ordered pair. X equals 1. Very good. So far, so good. And let's do an input, and we're done. We're going to input y to get x. So any good choices out there? Anybody want to give us a good choice? Ruthie? 4? Okay. 4 minus 2 is 2. 2 squared is 4. 4 times -1/4 is -1. So we input y to get x. So -1/4 is on the graph. That's 2 places above our AOS. So that makes -1, 0 also on our graph. And there's our final answer. Okay, I've got one more where we got to complete the square, and then I want to talk about a word problem, and then I'm going to turn you loose on this assignment. This time we're going to complete the square on x. Notice how x has the bigger degree. So completing the square on x means I'm going to have x minus 2 quantity squared. Now I'm out of balance once again by plus 4 on the left side. If we were to write this down, what it actually means expanded, it would be x squared minus 4x plus 4. So to make the two sides balance, I'm going to have to add 4 to the right. So I just want to make sure you understand that. Instead of showing it, I'm going to have this, and now my equation is in balance. And I need to solve it for y, so that's pretty easy. So I can tell how it's going to open. It's in what we would call true vertex form, what we're used to seeing as vertex form. So Emma, what's the vertex? Very close. It'd just be positive 2. Yeah, in the parentheses, you got to be careful. It's always the opposite the way it looks. This one's a little tricky. What is C? Can you go ahead and calculate C real fast using the formula? Absolute value of A equals 1 over 4C. A is just 1. So what is C there, Bailey? If you did cross multiplication, you'd get 4C equals 1, so C is 1/4. I'm traveling 1/4 of a space in which direction? How does this parabola open? Opens up, okay? From the vertex, so let's just kind of do it from here. I'm sitting here at 2, -8. I'll just go ahead and do the graph. 2, -8. And from there, since the parabola opens up from there, I'm going to go up 1/4 of a space. So if I go up 1/4 of a space from the vertex, where am I? What is the ordered pair of that point? Two, well, negative, right? Negative 7 3/4. Or you may have put it as negative 31/4 in proper fraction. So it's just slightly above the vertex. And then the focus is that same number, C, 1/4, but it's in the other direction. The directrix, I think I said the focus. The directrix would be the what line? So if you go down 1/4 and you draw a horizontal line, that would be the equation what, Stacy? Good. Or you could have said negative 33/4. And then I'm going to just leave it up to you. I think you know what to do now to sketch the graph. You're going to pick an input. You can pick anything you want. You have symmetry around x equals 2. And I'll let you take it from there and finish the graph. Okay? I want to go ahead and touch on this word problem because you've got one very much like it. So this is where we kind of put these problems into real life application. Satellite dish has this parabolic shape. The satellite dish, as you know, receives signals from satellites. They hit this dish and they bounce, and there's this tool. I don't know if you've ever noticed a satellite dish. There's a box-shaped piece of the dish that extends out a certain distance from the base of the dish, and it actually receives those satellite signals. So the bottom line, I'm kind of paraphrasing the problem. The bottom line is they want us to tell how far from the base of this parabola, and here's what I'm talking about as the base, how far out from the base should this receiver be placed. Okay, so what I've done here, I just drew a rough sketch of the satellite dish as it's described, But what you should do is just translate that into graph purposes, because that's what we're used to doing. So we're told that the satellite dish altogether is 10 feet across. Well, if it's 10 feet across and it's centered at the y-axis, that means 5 feet is on either side of the y-axis. So what you're doing here is using the dimensions of the dish in order to come up with some ordered pairs that actually fall on the parabola. So it's 10 feet across, and we're told that it's 4 feet deep. So that's how I came up with these ordered pairs, 5, 4, and 5, negative 4. 10 feet this way, and 4 feet this way. Okay, so with the vertex at the origin, the equation that I'm going to start with is this one, because I'm dealing with a parabola that opens up, vertex at the origin, so this is kind of like my starting equation. And I'm going to try to find out what A is, because basically what this involves is what is the focus of this parabola. If I know what the focus is, then I'll be able to answer the question. Well, in order to find the focus, I need to know what A is. Well, to find A, I'm going to use one of these ordered pairs, it really doesn't matter which, to plug in for X and Y. So Y is 4, X is 5, so 5 squared is 25. So what's A? A should be 4/25, right? Okay, so the equation, the basic equation that represents this parabola is y equals 4/25 x squared. Well, that's great, but it still doesn't answer the question. I need to tell what the focus is. Well, if I know what A is, I can do the absolute value of A equals 1 over 4c, and now you can solve for c and get the focus, and if you do, 16c is equal to 25. And does anybody have a calculator in front of them? 25 divided by 16, it's 1.625, I think, or 5.6. Okay, so now we have our answer. The answer is, and I'm not going to write it out, but it's 1.5625 feet from the base is where the receiver should be placed. 1.5625 feet from the base is where the receiver should go.